A very good day to Panastri. My name is Basha Naidu, daughter of Tyagaraja Naidu. My number metric is 01DT22F1030. So today I'll be presenting for question 1 and 2 in mini project, while my friend Vachana will be presenting for question 3 and 4. So for question 1, write a simple C++ program that insert a list of data into stack as shown in following figure. At the end of the program, show the top operations to remove all elements from the stack. Okay, right now I'll be explaining about the coding I did for question 1. First, I did character stack 3, and then integer array size equals to 3, and then integer top is equals to -1. First, I did for coding pushing the element inside the stack. So let's say if top is more than or equals to array size -1, the output will be stack is overflow. Let's say if not, it will show the element that's supposed to be pushed inside the stack. Next is the element that's supposed to be popped out of the stack. So let's say top is less than or equals to -1. The output will show that stack is underflow. If not, it will supposed to be showing the element that was popped out of the stack. Next, if top is more than or equals to 0, the output will show the elements that have been inside the stack. Let's say if there are no elements inside the stack, the output will show that the stack has been deleted and it is empty. And at the below we can see that I've inserted PUO, which were the elements that inside the first question of the stack. And next, I will display the output of the coding I did. This is the output that I got for coding question 1. The elements that were pushed were element P, element U, and element O. When top is equals to 2, element that were pushed, element that was popped is O. Top equals to 1, the element that was popped is U. When top is equals to 0, the element that was popped is P, and the last outcome is that the stack has been deleted and is totally empty. Next is question 2. Write a simple C++ program that insert a list of data into Q as shown in following figure. At the end of the program, show the dequeue operations to remove all the elements from the queue. Next, I will explain about the coding I did for question 2. Next, I'll be explaining about the coding I did for question 2. As we can see, the character Q is 3, integer array size is equals to 3, integer front is equals to 0, and then the rear is equals to -1. First, I did the coding for in Q. So rear is equals to size -1. The Q is full. If not, if the front is equals to 0, the rear will show the data. It will show the element output for element front and rear. Next is dequeue. Let's say if front is equals to and only is equals to -1, front is more than rear, it will show that the queue is empty. If not, it will show the element deleted from the queue is, and will show the element that has been deleted from the queue, and then will show the front and the rear. That's all for this part of the coding. Next, first I inserted the coding to display the queue. So the output will show the element inside the queue is, and will state down the elements inside the queue. Let's see if front is equal to size, the output will show that the queue was deleted and is empty. Next I have done the coding as what have been asked by the question. As we can see, elements that were in queue were P, U, and O. Next was the elements that were dequeue. So as we can see here, it was dequeued 3 times as that has been asked in the question. That's all for the question number 2's coding. Next, I'll be explaining about the output I did for question 2. It's about NQ and DQ of Q. Element inside the Q is P, front is 0, rear is 0. Next, the element inside the Q is P. Element supposed to be inserted inside the Q is U. Front will be 0 and rear will be 1. The element inside the Q is P and U. The element supposed to be inserted inside the Q is O. Front will be 0 and rear will be 2. Next, the element inside the Q is PUO. Elements that were dequeue. Elements deleted from Q is P. So front will be 0, rear will be 2. The elements inside the Q is U and O because P was deleted. The element deleted from the Q is U. Front is 1 and rear is 2. The element inside the Q is O is because the element in the past coding, the element U was deleted. Next, element deleted from the Q is O. Front 2 and rear 2. At last, the element inside the queue is nothing. It's because the element P, U, and O were deleted in the previous coding. the last outcome of this output was the queue was deleted and is empty.
A very good day to Puanastri. My name is Varchana Anapram Pandil Kumar and my metric card number is 01DDT22F1143. I'm going to present question number 3, which is write a C++ program to show implementation of binary search tree using linked list. Your program must include all the operation in binary search tree, including creating BST, inserting item into BST and count item in BST, and also deleting item from BST and traversal of BST. So now we have to do a simple coding to enter the size of BST. After we enter the size of BST, we need to enter the value for the root of coding. Then after that, enter the value for the node. So then the left node for the new tree code. After we enter the left node for the new tree code, we also have to put right node for the new tree code also. In this part, we have to enter struct for the smallest node in the tree and insert struct tree for delete node. So after we insert struct tree for the delete node, we have to insert the struct tree point for the root of right and left, and also insert the void for in order tree point. So we have to insert the coding for pre-order point left and right. So after we insert the coding for pre-order, we have to insert the coding for post-order point also for left and right also. Then after we insert the coding for pre-order and post-order for left and right, we have to create the traversal in order, traversal pre-order and traversal post-order. Furthermore, we have to enter the code to calculate the total number of node and enter the code to confirm whether to delete the node or not, and also to confirm which node to delete. At last, we need to enter the code to calculate the total number of node after deletion. So now we are going into the very important part, which is output. So as you can see in my slide, we have to enter the size of BST 3 and then value for the root 23 and value for the node 45. So value will be entered in the right. Then we have to enter the value for the node 67. So value will be again entered in the right. The BST that was constructed. So traversal in order is 23 to 45, 45 to 67. Then traversal in pre-order is 23 to 45, 45 to 67. Traversal in post-order is 67 to 45, 45 to 23. The total number of node is 3. Do you want to delete? If you click yes, you have to put 1. If you click no, you have to put 2. So here I click yes, so 1. So and then you have to choose whether which node you want to delete. So 45. Again it will ask, do you want to delete again? If yes means click 1, if no means put 2. So here I put no. So after deletion, traversal in order is 23 to 67. Traversal in pre-order is 23 to 67. Traversal in post-order is 67 to 23. The total number of node after deletion is 2. I hope you all understand. Thank you. The next is question 4, which is based on figure below. Illustrate the steps to find the key of 50 by using binary search method. So to find the target value, we have to use binary search method. Our first step is we need to set target, which is 50. Our second, third, fourth step is we have to find the first value, last value and mid value. So in this case, our first value is 0. Our last value is array size minus 1, and then our mid value is first plus last divided by 2, which is 4. So we have our first value, last value and mid value. And then our fifth step is we have to see whether the mid value is equal or not equal to the target value, which is 34 is not equal to 50. Our sixth step is we have to see whether the target is higher or greater or lesser than the mid value. So our target value is higher than the mid value. So we have to draw the diagram again and then we have to mention the first value, last value, mid value again. So if the target is higher than mid value, we have to plus the first with 1, which is in first we have to plus the 4 mid value with 1. So 4 plus 1 is 5. And then last value is the same, which is 8. And then mid value is 5 plus 8 divided by 2, which is 6. So our new mid value is 6, which is 47 is not equal to 50. So target value is greater than mid. We have to draw the diagram again, and then we have to find the first value, last value, and mid value again. So if the target value is greater than mid, in first we have to plus mid with 1, so which is 6 plus 1, 7. And then last is remains same, which is 8. And mid value is 7 plus 8 divided by 2, which is 7. So we got our mid value 50. Now our ninth step is we have to see again whether the mid value is equal to target value or not. So our mid value is now equal to target value, which is 50 equals to 50. Our last step is display target found. I hope you all understand. Thank you.